Earlier in the course, you may have heard me refer to C# and .NET as a managed code environment. What that basically means is that the .NET framework provides automatic memory management for you. You, as the programmer, are not responsible for freeing up the memory that your program's objects use during the course of the running of your program. Now, this is not like other languages. In languages like C and C++ and Objective-C, you as the programmer, when you create objects that take up memory, you are responsible for making sure that that memory gets returned to the system at some point. But languages like .NET and other languages like JavaScript and Java and so on, those are managed code environments. There are ways that the system figures out that memory is no longer being used by your program and reclaims it automatically. Now, to take a simple example, when you do something like this in your C# program, you have some object type definition, maybe you've made a new class, and you use the new operator to create a new instance of that object, that allocates memory somewhere in the system. That tells .NET, hey, you've got to go find some memory to hold my object. And the framework will take care of figuring out when this object is no longer being used. You don't have to do anything special. .NET will just figure out that you're done using this object, and it will put the memory back in the system for you. So let's take a look at conceptually how this works. There's a big pool of memory available to the system, and we can think of it as this big purple box you see right here. Now, your program is going to use this memory during the course of its operation. And as your program runs, it's going to allocate blocks of memory. And when it does that, those blocks of memory are going to be taken out of the system memory pool and assigned to your program. Then your program will do whatever it does with that memory and all these objects. At some point, there's a special class in the .NET framework called the garbage collector. And garbage collection is the process by which .NET figures out that memory is no longer being used by your program and can take it back into the system. So the garbage collector has a way of keeping track of the objects that you've allocated. And when it figures out that these objects are no longer being used, it simply puts them back in the system memory pool. This process is completely invisible to your program. You don't have to worry about doing this at all. It all just happens for you. So let's take a look at how garbage collection works. Suppose we have a function, looks like this, it's called myFunction. And inside myFunction, I've got this new my object. Well, out in the system memory pool, when I do that, a block of memory is going to be allocated that holds my object. That creates what's called a reference. That myObj variable that you created inside your function is now going to hold a reference to that memory location. Now, you can go and do a bunch of things. You can call a method, you can set a property, you can call some other method. But when that function ends, that myObj variable is going to go out of scope. And at that point, there are no more references to my object. Because that variable is gone now, that little reference line disappears, and the garbage collector comes along and says, hey, no one's using that thing anymore. I can just return that object back to the memory pool. So, what are some important things to know about garbage collection? First, your program does not need to initiate this process. The garbage collector figures out when it needs to run and reclaim memory. Now, there is a way for your program to initiate garbage collection, and we'll actually take a look at that in an example in just a bit. The garbage collector balances between performance and app memory usage. And the objects are not necessarily reclaimed right away. So these two things mean that you, A, don't know when garbage collection is going to happen. The garbage collector tries to figure out how your program is doing its work and how much memory it's being used. And it tries to strike a balance between making sure that your application doesn't take a performance hit while figuring out how much memory is being used and trying to say, okay, well, memory usage is getting kind of high. Maybe I should go take some of that memory back. The other thing you need to realize is that when you're finished with an object, it might stick around for a while until the garbage collector figures out that it needs to run. Now, objects can detect that they are about to be released from memory. So when you create an object in a class, you can actually write a method called the finalizer. Now, this is rather advanced. I'm not going to cover it in this course, but you can just be aware that there are ways for your objects to figure out that they're about to be released back into the system memory pool.